Is there any lag? I mean, not any lag, but I just need lag. Any streaming? I don't know, man. Oh, let's wait for a minute. I think it will start, so let me start it. Okay. Hey guys, I don't know if you are going to watch it today or maybe in future. Welcome to the high entropy, and it's day 33 of. Not any lag, but I think network issue because I see like I don't know, man. It's streaming, but I don't know why it's work. Let's wait for him. Okay, so it's day 33 of DSA learning, and I'm on like I have finished so far. I finished array problems, and now I'm solving binary search, and after that the plan is to start dynamic programming. So yesterday I was trying to solve a hard problem, and I felt like okay, actually I have to go for dinner, so that's why I had to go for dinner. So I was in a hurry and I wasn't able to solve that problem. But what I did, so simply like I just copied the solution because I do not wanted to break my streak. Okay, I think I need to speak little slowly. I got like a feedback from multiple people, so that's why I'll speak little slowly. But okay, so if you are watching for the first time, welcome to the high entropy, and here I'm on a mission. I'm again speaking a little faster. Okay, so first thing, like welcome to the high entropy, and here I'm on a mission to improve my DSA journey, to improve my DSA problem solving skill. And earlier, like when I was in college, at that time I was used to solve the problems uh, using the C++ programming language. But recently I switched to Python, and the reason behind it is it's not about the Python whether you are uh, using Python, C++, or Java. It's up to you. You can choose any language. Most of the time, the most important thing is like when uh, it's not about is yeah, definitely it will, like you will get A's when you are solving the problem using C++. But if you are talking about interviews, then most of the time interviewer don't consider or don't focus on the language that you are choosing. They are focusing on the algorithm that you are using to solve the problem, algorithm or the method that you are trying to solve the problem. And yesterday I was solving a problem. It was a hard problem. So hard is not the hard, you can say. It's more about the problem that I was trying to solve, and there were some mistakes that I did, and because of that it wasn't working. But after that, like once I came back after having dinner, I tried to solve it and I solved it. So okay, so let's jump without wasting your time or my time. Let's jump into the work that is important for us, right? And today, though I'm starting at 9:19, so I'm targeting like I'll stream it till 10:30 at least. So today I'm not going out for dinner. At least I'll go out, but after having dinner. So today I just scheduled uh, an order. You can say from Zomato. So they will deliver after 10:30. So it would be delivered between 10 and 10:30 and 11. So that's why I have chosen the perfect timing. Like it won't disturb me in when I'm streaming. Okay, so yeah, let's jump to the this. So far we have solved till here, and here if you know this problem was little tricky for me as I was trying to solve this for the first time. So it was completely new, but I came to till the approach, and I thought and few things were where I need to take help. But even after that it wasn't working. But if you notice, like I tried to solve it after, like once I so if you notice, I used the same approach that I was using to solve it earlier. If you can see it here, I'm counting all the number of possible outcomes or possible values. Only the tricky part is this is for the first time I'm solving for a problem where we need to deal with fractional value. So this is new tricky part. Yeah, definitely I'll remember it for some time. After that it will be um, I will remember it. I mean, it will be used to like once I'll solve few more problems related to fractional value, then it will be easy for me to okay, I need to use this kind of algorithm, or you can say. And if you're talking like yesterday I was watching a podcast, and it was between Chris Williamson or Williamson Chris and Raj Shamani, and the person like Raj Shamani podcaster was asking to the guest that he feels like he was copying that person, the who guest, and then he stopped watching his videos. So that time the person guest mentioned like, okay, but you know what, we always feel like we are doing something new, but we are not doing something new. We are just we get influenced, or we take some from someone. Like you are watching a lecture and after that you are solving problem. It's not like you are doing something new. You are just copying someone and you are making your modification or adjustments. So it's like a, you can say you are doing something that is undetected plagiarism. I don't remember the exact sentence, but yeah, it's like whatever you are doing, and it feels like you are doing original until it's basically you feel it's original, but it's undetected plagiarism. Okay, so so I like that. And here, okay, so we solved this problem, and here if you see, you just took the low and get max. I don't think I need to repeat it because I already solved it, and yeah, but this is a pretty interesting problem. I Okay, now let's jump to another problem, and we'll see like how to approach it. And definitely, I'm gonna solve it in a whiteboard first. Then we'll jump into the coding, because coding is not tough part, and if you have right approach, okay. And yeah, definitely, consistency is helping me a lot, definitely. And if you are also solving problems, then definitely try to be consistent, irrespective, like either you are solving one half problem, but be consistent. Try to attempt every day. It will help you and you will see the progress. And I feel like I'm making progress. And it's pretty much about endurance, and you are the dedication that you are uh, making towards your goals, and the time that you are giving, the undivided time to be precise. It's pretty important. So let's jump into the problem and let's see. So given two sorted array 1, array 2 of size m and size n respectively, return the median of the two sorted array. First I learned somewhere what is median, not medium. Let's see example and let's try to analyze it. The median is defined as the middle value of the sorted list of numbers. In case the length of the list is even, the median is the average of the two middle elements. Okay, perfect, great. So we have two arrays and we need to find out the median of the array. You can say like when you are merging both. So I know naive approach would be something like you just need to merge both arrays and sort them, and sorting, you don't need to sort again, so you can sort them using the approach merge two sorted arrays, and you will get a, you can say, order of log m plus n. You can say whatever the value, if one has length of m, another one has length of n, then it will take m plus n. It will be comparatively easy because these arrays are sorted. You don't need to apply sorted algorithms, otherwise it will take time of order of log m plus n, log m plus n, and you want to optimize it, right? So that is one naive approach I'm telling you, but I'm not gonna attempt that naive approach because it's already in my mind and I can solve it. So we'll jump to optimized approach. Simply, yeah, I'm pretty much focused on a optimized approach, and I never solved, I believe. Let me see if I made any submissions. Yeah, so it's I'm attempting it for the first time, but I feel like it's comparatively easier as compared to the last problem. Last one was little tricky. For few minutes I wasn't able to see what exactly I need to do. Okay, so we have two arrays. Okay, we need to find the median of the arrays, or you can say median of the sorted arrays. Great. Here also we have two arrays. I'm pretty happy, man. I don't know. I'm just trying to keep myself calm, because I always don't be in rush when you are attempting problems. Just keep your brain calm, otherwise you will mess up everything. I noticed it so many times, like whenever I'm trying to solve in at the real time, I always get stuck and I feel, okay, let me jump to another problem, and neither I'm solving the first problem nor second nor third, and then I get panic. um, I get panicked, and after that, you won't be able to solve even single problem. So you stuck to one problem or whatever. First, maybe you just go through all the problems. Most of the times, when we are attempting any assessment, we are getting three problems and 3 hours of duration. Always, most of the times, what I'm saying in ideal scenarios. So we have given two array 2, 4, 6, 1, 3, 5. Let me note down first, and then we'll see how to approach it. I don't have any approach right now. I just know we need to use as the topic is binary search, so I don't need to think too much about anything as of now. But once we'll solve some blind 75 or other, then definitely we need to think from all perspective. For the time being, we can stick to binary search, and we'll try to apply binary search if possible. Okay, will be possible. So these are the two numbers, array 1 and array 2, and we need to find out. And let me note down another example. Oh, okay. Yeah, so next time I'm just using full screen, so you will see completely my screen, this one only, at the time when I'm recording. So we have array 1, and we let's skip the second part. We have these numbers. This is array 1, array 2. Okay, now we need to find the median of this. If you notice, oh, it's little. So what I'm thinking, let's say its size is m, its size is n. Okay, pretty cool. Sorted, sorted. M and n. So total elements are m plus n. What if it was a single array? Let's say, just let me assume if it was a single array. Then how are we going to approach? Let's say, first let's think about like this: 1, 2, 3, 4, 5, 6. It would be like something this. Then m plus n, 3, and 3, 6. So m plus n will be 6 or 3 plus 3. Okay, 6. So can I say then it would be very easy, right? Simply we need to check this one, and we need to check this one. What is the index of these two? Oh, no. Then we don't need to check even these two. Simply we can say just find the m plus n by 2 if perfect number, perfect, get that, perfect division, get that, else get you can say integer part will be like, suppose you are getting 2.7 or 2.5, let's say. So you can say 2 and 3 will be the part of it, and you can get integer plus 1. I'm just using some analogy, integer plus 1, and take average of them. I know I'm not anywhere approaching towards solution. I'm just trying to deduce if I can get something from it. So far we are not going to get anything from it. So what else we can utilize if we are talking about these problems? I know M can be of any size. N can be of any size. So, bro, what will be the logic to solve it? Okay, let's see the constraints. How much M can be, the size of M is between 1000, 1000, M plus 1, M plus N will be 2000. Okay, so it's not about, you can say it's not about the, like if it is 2000, then definitely you can apply M plus N sorting algorithm, but let's forget about that. So we have M, we have N. Okay. So first thing is both are sorted. One, 3, 5, 2, 4, 6. Is there any other information that we can use? Given two shorted array are given of size M and respectively return the median of two shorted array. Median of two shorted array. After merging will be this, and a length of merged even median is the, okay. So how can I apply binary search? After merging, the problem is not 2, 4, 6, 1, 3, 5. Is there any relevance if I'm using this? Oh man, what is are you doing? Two, 4, 6, 1, 3, 5. Hmm. What if I'm using binary search somewhere? Can I apply? Okay. Okay. What if I'm talking about min? Min will be 1, max will be 6. So 1 and 6. And what is the number of size of the number? I mean, what is the length of? It could be between minus 10 raised to the power 6. So definitely you can say range varies between total 10 to power 7 plus 1. Okay. So here what else? 2, 4, 6, 1, 3, 5. I'm not getting anything from this problem. 2, 4, 6, 1, 3, 5. Let me see if I can get something. I'm just trying to think out of box. Bro, something I'm not able to recognize. If some hidden logic is missing here. 2, 4, 6, 1, 3, 5. And if we are sorting them 1, 2, 3, 4, 5, 6, it will be something like this. Here if you notice, like it feels like it's basically we need to take medium of both the numbers, but not. What if numbers are like something like this? 1, 3, 5, 8, 9, 10. Then it will be something like 5 and it. Binary search. Okay, if I would apply in binary search in 1, then it will be something like, let's say 1, 3, 5. What we are doing in binary search, just take mid and try to find the mid of this number. I mean, yeah, basically our goal is to find the mid of this mid in the range. So it will be like 0 and this number whatever we are getting, 0, 1, 2, 2, and just try to find the mid. 0 plus 2 by 2. I'm getting called. 0 plus 2 by 2. I'm not getting any insight from this. Crazy, man. 9:41. Oh, hold on. Okay, 9:41, 9:41 a.m. I got confused. Okay. Is there anything that I'm missing? Here it will be mid of this. Here it will be mid of this. No man, it's like how much time I did I spent? Bro, it's completely off. One, two, I mean, what else I can do? 1, 3, 5, 2, 4, 6. I can't count down my weapon. 1, 2, 3. What about other example? What was it? 2, 4, 6, 1, 3. 2, 4, 6, 1, 3. So it will be like 1, 2, 3, 4, and 6. And it will be 3. Did we? Now I'm just thinking. They are, uh, if you notice, they are giving the number that is 3.5, and here they are giving 3. So what I'm thinking, something like if I need to do fraction and I need to apply binary search on both the numbers and need to check. Okay, let me think from another angle. Right now I'm not thinking from that angle, I believe. Okay, so let's think. Let me think. Okay, I mean, yeah. So definitely, if we think about it, it will be something like start can be, we need to take mean. Okay, so mean will be nothing but the starting number, that is lowest number, so 1. And if we are talking about median, and max will be the high will be low, you can say, and high. I'm it will be nothing but you can say 6 will be high, definitely based on this. And we need to look for the number. And what value it could hold. At max you can say always we are going to divide two numbers, so division of any two numbers is basically 0.5. Definitely we are going to get x at max 0.5 you can get. Oh man, I think I'm approaching towards it. So every time you are, whenever you are doing, you can say, yeah, perfect. Definitely, whatever the number that you will get whole number, and you need to just see what will be the value of it. Okay, I think I'm approaching towards it. About no. Let me think more about it. Okay, so we just get the number. Huh. Okay, so I mean I got the number, but how will you justify like whether it could be medium? Can it be medium? I mean, yeah, just we need to count. So total are m plus n number, and just we need to check the numbers that are smaller than this number. So we can check in these two areas how many numbers are smaller than this. I mean, I can apply binary search. Hey bro, it's like two times I'm applying binary search or what? One binary search to find the number. I mean to assume the number. To okay. And second will be to find out the index and whatever the number that we are getting from this index, we can say where the number are smaller than this, then we'll say okay. How long it will it take? Am I using the right approach? Oh, so many questions. Let me think, or let me say how I'm going to proceed if I'm using this. So low, okay, let me zoom it, bro. So low will be something like you can say min of array 1 and array 2. Now it started behaving up normally. Hey, every day I'm facing the same issue, like it's not working properly. It's pretty awkward. Let me write slowly. High will be something like you can say max of array 1. I will kill it. Is it happening with everything? Oh man, it's working. Shall I switch to this one instead of whiteboard? Hey, good notes. Start working properly. Otherwise, I'll switch to notebook, and I'm paying for you. Paying for you. It's good phrase or what? Okay, so these two things, and then I'll get low. I'll get mid, and whenever mid is matching, if it's matching, that means yeah, that's the perfect number. Good. Okay. And if it's not matching, I mean, if we are getting extra numbers, what does it mean? That means, I mean, if we are moving forward, you mean the number of the index that we are getting and left numbers are more at left side, right? That means if you are getting higher index than expected, then that means okay, more getting more. So we need to reduce the number. So you can say high will be mid minus if bigger. Oh man, I hate it. Okay, then high just we can say medium minus 1. I mean, yeah, medium minus zero point 0.5 just need to do because the divisions will be point. But what if I do zero point 0.5? No. If I'll do zero point 0.5, then the problem is I'll get the number. I'm looking for a normal number, right? Let me see. So, let me switch here. If it was something like this, man, I'm just using different rough things to buy. Study with me in 2db. Actually, I was planning to create something and now I'm not creating. Okay, so here let me note down first. So what I wanted to say. Suppose it is something like we have a number 1, we have 5, medium is 5. Then what we'll get? If we'll do like mid, then we won't get the same number, right? And I just need to the numbers that we are looking for mid should be whole number, or it should be like a 1 point something like x point 5, that like that, not that like that. So suppose it's like 1, it was earlier 0.5. I don't know why I'm writing like this. Okay, here rough is not working, so let's say medium was like 3.5, so we need to change to 3. Yeah, so just we need to reduce 5.5 here. But bro, I'm just thinking, is this right approach or just I'm deliberately trying to solve it using this approach? Like I was, what happened with this? Oh my god. Okay, OMG. So here the problem is, it's not a problem, it's you can say, what is time right now? Before someone uh, ring the bell, I just want to finish it. Okay, so low, we get high, we get mid, and now we need to check if mid can be the result. So for getting mid, we need to find binary search. What are the numbers that are before mid? Okay, so let me just try to do it. Oh man, you just go and minimize. Yeah, now perfect. Where is my Chrome window? So 1, 2, 3, 4, 5, 6. Okay, 2, 4, 6 and 1, 3. Let me note down it in the 2, 4, 6 and 1 and 3. So let's use this algorithm. I believe it's perfect one. Not perfect one, but I'm sure like we can use this algorithm, but still I'm just confused. Why are we using binary search? How it's going to help us? I need to think more about it. If I'm using, suppose this is size of m and this is size of n, so then total time will take order of m plus n. But if I'll use binary search, then I know the total size is m plus n, but we need to find the min and max. So you can say log of 10 to the power 7, you can say. This is one thing. and we are applying binary search on both. So you can say log of into log of m plus log of n. Yeah, this is the time that it will take. Still, it will be easy. Comparatively, it will be lesser time, right? Yeah, definitely it will be lesser, very much less. So what I'm thinking, okay, I'm telling you the approach first. So first there will be one binary search, top PS, that will be about guessing the median value. And whenever you are going to get median, it will be either whole number or it will be fractional value. And fractional is also constant, like you will get, for example, you have divide two numbers, then it will be something like a maybe suppose you are, when you are taking two integers and you are dividing by 2, because you are taking average of them, right? Then it will be like something, you will get x.5, right? So say, definitely we can say like every time you can take zero point 0.5 step back or zero point 0.5 step forward and you will get the numbers. So that's why. So you will be, let's take low will be nothing but min of, you can say min of array 1 and array 2, and high will be max of array 1 and array 2. Okay, so these are the two things that you will be getting. Man, how can I minimize it? Yeah, leave it. It's like also big canvas. I was using. Okay, so this is one thing, and after that, simply we need to use while low less than equals to high. Yeah, right. And mid will be nothing but, you can say, low plus high by 2. Here we will use 2.0 because we need fractional value, so we can't blindly use integer. If you remember, last time I used, not I used, but I got it from them. Okay. Second thing, if check, we are going to check. I have a habit of just use what needs to say. Scribe and erase. It will be like you are, if you are doing like this, and it will automatically erase in uh, good notes. But here it's not working like that. I'm taking still, like I'm processing the words. Sometimes it's not coming under. I'm taking pause, but no problem. That we'll fix it soon. So I'm working on it basically. So we have, okay. So we got mid. Now we need to check. So let's say, oh man, it's pretty hectic habit of me. Let me. So first we need to check if possible. I'm using this function only every time. And here we need to pass array 1, array 2, and you can say mid. And that is enough for it. Possible. So we are going to check, not check, okay. What we will check if possible, or just get the count, get index, you can say get index of first, get index of second, or get total index, maybe you can say the number of elements that are before it, and it will return that. Okay, so because we need to find out all the elements that are before this number, then only you will get, right. And you can say, okay, am I in the right direction? Yeah. So you will get count, and if you can say it's greater than mid, if equals to mid, whatever the mid value that you are going to get, okay. So what I'm just saying, I mean, yeah, just we can calculate like whether the number of possible outcomes based on the mid, we got the mid and we got the count, and if it is equals to the number of that we are looking, if equal, I mean if it is matching with the value, or it is equal that we are looking for the median, or we don't know the median, what should be the numbers. For example, based on odd and even we can decide like what will be the number of elements that will be before it and that will be after it. So okay, so if equal then it's okay and return result. And if it is not, if it is like if we are getting more elements in the left direction, then if greater, if lesser, that means you can say we need to increase the median value, then only we'll move towards right direction, right? Yeah, right. If it is lesser, we need to move, like we need to increase the mid value, so you can say low will be nothing but mid uh, plus 0.5. Here one thing is tricky. Else elif, you can say elif else, you can say high will be mid minus 0.5. And check if possible what needs to be done. I'm writing like function or what? Check. I'm taking too much time, man. I just want to solve it from my end first, then I'll see if not, it is not working, then this is the best what I can think as of now. So I'm going to use this solution. So we have array 1, array 2 and mid. So first thing is like we need to look for the number mid. So you are going to apply binary search here, and you are going to apply binary search here. Okay, and then whatever the index you are getting from this, whatever the index you are getting from this index. So basically you can say if you are going to place this number after this, then definitely you have to sum them and you have to return them. Sum and return. Still I am writing algorithm only, not approaching towards solution. So let me try it first. How are we going to solve it? Oh man, he's calling right now. हेलो फोन नहीं भाई मैंने कहीं नहीं किया ठीक है oh man what is this okay I don't know if it is working or not huh camera got off camo come on okay I'm sorry like it was way I got called from Ecard. I don't know why. Maybe my brother called him. And he was asking like, have you called me? Like I see a missed call. Okay, bro. So here let's jump to the solution first. So let's take the example and let's try run. So if you know 2, 4, 6 and 1, 3. 2. Oh, hold on. 2, 4, 6. This is 1 and 1, 3. So first thing will be we need to find out mid. So low will be nothing but you can say it is 1. High will be 6. So mid will be something. Okay. Mid will be nothing but 6 plus 1, 7 by 2, it will be 3.5. And here we are not taking 3, if you remember, 3.5. So we are going to check, can we say it's 3.5? So how many numbers are before it if it is median? So you will see, you will apply binary search on this number. So you will start from this number, and you will see binary search. What is the index of it? So how we are going to apply binary search? We'll talk about it. But for the time being, let's apply this linear search first. Okay. So if you are going to say, okay, this number, this looks smaller than this, and after this will be larger than this, then you can say one number will be here, and how many numbers are there? These are the numbers that will be before it, and after that this number will be placed there. So we can say there are three numbers that are coming before it, 3, and after 2 you can say 2. So can I say, okay, now it's getting little tricky. I need to handle corner cases. If it is if the numbers are equal, that means we are looking for the number. hmm where the numbers will be something like this. Okay, so 3 to 5. 5 means, okay, total are 5, so that means two numbers will be before it and two will be after it. That means, okay, so this is not the case. So you can say 2 should be before it, but we are getting 3, so definitely it won't be, like we are getting extra. So this number won't be 3.5. And now we need to check another, we need to look for another number. So if it is bigger than this number, that means we are getting extra numbers before it, and we need to shift numbers. I mean we need to reduce the number so that we can get. So what we'll do, low will be the same 1, and mid will be we'll divide it, we'll reduce 0.5, so 3. So 3 plus 1, 4 by 2, that will be 2. So 2, we'll see 2. How many numbers are greater than this? How many numbers are before it? So you will see, okay, 2, that means this number. So 0 in this one, and how many numbers? 1 in this one. So we are getting 1 number. So that won't work, so we need to increase the number. So low will be 2, low will be what? Yeah, low will be nothing but mid plus 1, mid plus 0.5, so 3.5, and high, wait a minute, what I did, my bad. Low was this, mid was this, so low, what I did, bro, mid was 3.5, so it wasn't working, so this was high. I did something wrong. I'm taking too much time. High is 3. I'm not able to solve it, or what? Low is 1, high is 3. So low plus high, this is like 3 plus 1 by 2. That means 2, you are getting 2. And 2, when you are checking 2, it is smaller than this number you are getting is smaller. Mid is 2. No man, just have patience, and sometimes it's not working. Mid equals to 2. No problem. I'll take more time, but I'll solve from my end first, then I'll approach and I'll see the solution. So mid is 2, then it's like we are getting one number before it when we are looking for the numbers that are smaller than this. So mid will be this, and now I can say, okay, so this is not working. I need to increase the low. So low will be 2.5 and high will be 3. So 3 and high will be 3 and low will be 2.5. So 3 plus 2.5. Hey, this will be wrong, right? Hmm. If I do this, mid is 2, bro. So see, that's why dry run. I'm failing here as well. 2.5 I'm getting, and if I divide them, then definitely I'll get different fractions, and that won't help. But logically, it should be something like 2. Get the number between 2 and 2.5 and 3, because 2 is not working. So 2, it could be 2.5 or it could be 3. So can I say try to find the number between 2 and 3? Then it will be like mid of those two, 2.5. And what if I was checking here? Something messed up. How much time I took? It's like 14 minutes here passed, and let me see the hints. If focus only on locating the required. My approach is wrong or what? What if arrays have different sizes? Divide both arrays into two halves such that the left halves contains. Oh man. Okay. First thing is, instead of merging the arrays fully, focus on locating the required middle elements. Focus on locating required middle elements. But how would I know what will be the middle element? Okay, what I'm thinking, maybe no, it won't help. Oh god. Now I'm a little panicking. Instead of merging the array fully, focus on locating the required middle elements. But based on how can we just what is the middle element? Editorial, let me see. Here's the idea to use binary search algorithm to optimize the approach. The primary objective of binary search is to observation. Assume n size of both array. Characteristic of each half is that it contains n by 2 elements. Each half contains elements from the configuration of two halves unique. So we can try to form halves with different value of x, where x number of elements taken from array 1 for a particular half. Okay. No, my approach is completely different. It's not work. Wait, still they are using no. I mean, let me jump to tutorial. I think I'm not able to solve it or what. Yeah.
So the problem that you're going to solve today is finding out the median of two sorted arrays. Now this word is very important, sorted, because that is what will help us to solve this problem. Now you can be given two arrays of equal size. You can also be given two arrays of different size. Like in this example, you can see this array is of size 6 and it is sorted. This array is of size 4 and it is sorted. Now what you have to do is you have to find the median of these two sorted arrays. So what you have to do is you have to take both of the sorted arrays and you have to combine them. So if I combine them, what I get is 1, 2, 3, 3, 4, 6, 7, 10, 12, 15. What is the total number of elements? The total number of elements in this case is 10. Why? Because n1 was 6, n2 was 4. So the total number of elements is 10, right? So if I try to find out the median, can I find a median of 10 elements? I cannot. Why? Because if I stand over at 4, there are 4 elements on the left, there are 5 elements on the right. If I stand at 6, there are 5 elements on the left, 4 elements.
Okay, I got one thing from this, like why my approach won't work, because numbers can be negative, right? And I was thinking about the positive numbers only if you talk, because yeah, definitely. Else, maybe if you notice, like I was taking my negative number, not negative number. No, but I was taking min of that number, na. So let's say low plus high by 2. Will binary search work? Let's see. We'll take this. Let's for the time being. Let's. Oh man, feeling bad. It's second day. I'm just watching tutorial again, and I'm not
On
able
the
to
right.
solve them.
So there is no specific median because median means on the left and on the right, there must be equal number of elements. Now this is not in this case, this is like 5 and 4. They're not equal. So can I say the median will be somewhere between 4 and 6 because if I take somewhere between 4 and 6, on the left there are 5, on the right there are 5, which is equal. So I can say that the median is somewhere between 4 and 6. So it's like the middle of 4 and 6, so 4 plus 6 by 2. 5 is the median in this case. Now over here the point to notice was the total number of elements was even. That is why it did not have a specific median. But what if I take this example? There's like 3 elements, there's like 2 elements. So what is the total number of elements? Can I say that the total number of elements in this case is 5? I can. So if I try to combine them in this time, what will I get? If I try to combine them, I'll get 1, 2, 3, 3, 4. If I ask you what is the median, can I say this is the median? I can. Why? Because it's like two elements on the left, it's like two elements on the right. Thereby, the median is pretty simple, the midpoint. So, in case of the total number of elements being odd, it's very simple. In case the total number of elements is even, I have to consider two elements and I have to take the middle of it. Got it? Now, this is what we have to find. We have to find the median of two sorted arrays. So both the previous solutions were taking a bgo of n1 plus bgo of n2 time, and yet we did get a time limit exceeded when we tried to submit
How to
it.
increase
Now this is a linear time complexity. If we have to optimize it, what can be the optimization of it? Somewhere around square root or somewhere around logarithmic. That is how we can optimize this. Square root I will not consider as of now. I'll consider logarithmic. Why? Because of this thing, sorted. We know in sorted stuffs, we probably can apply binary search. And binary search is an algorithm which works in logarithmic time. So that is where the intuition comes in from, because the linear did not work. And it is given a sorted, we'll start thinking of a binary search solution. And if it doesn't work, then we can think of something else. But the first hit point should be binary search solution. So what I've done is I've taken two arrays. And if you sum up their elements, that is 10. The total number of elements is 10, which is even. So let's first understand the binary search solution in terms of even number of elements. Once you've understood the concept, then we can easily switch to odd. Once you've understood for even, it's very easy to switch to odd. So as of now, you might be thinking, but how do we apply binary search? Because till now we have seen in an array, we did a search, we used binary search. If the search was on answers, we did on binary search. But over here, how do we apply binary search? First thing, we have two sorted arrays, and we're trying to merge them into a third sorted array. And in doing so, we're finding out the median, right? If we try to draw a symmetrical line on that median, on the left, there are 5 elements. On the right, there are 5 elements. Notice this symmetry. Okay, next step. Out of these 5 elements, how many are coming from array 1? Can I say 1, 3, 4? So there are 3 elements from array 1. Agreed? And there are 2 elements from array 2, right? On the right, there are 3 elements, the rest 3 are on the right, and the rest 2 are on the right. So this is where we'll start our binary search. We will try to formulate the correct left half. We will try to formulate the correct left half. If we are able to do that, we can actually find out the median. How? Let's understand. Imagine you formulated the correct left and you formulated the correct right half in hypothetical scenario. Then the median will be 4 plus 6 by 2, isn't it? Right? So our task will be to figure out, okay, 3 elements from array 1 and 2 elements from array 2 will formulate the correct left half. Because one thing I'm very sure is the left half will be this itself only. Will be this itself only. It cannot be anything else. It cannot be anything else. Right? How to do this? Let's understand. Let's do the strategic linear search and we'll try to do it, build on it. So, we're trying to build the left half and we're trying to build the right. So imagine I say you from array 1, because we know we need 5 elements. What's the linear search? Like where does it start? Maybe pick up 0 elements from array 1, I'll pick up no one from array 1. I'll pick up no one from array 1. If I pick up no one from array 1, what will happen? In that case, I'll have to pick up 4 elements from array 2, because how many do we need on the left? We need 5. So if I pick up no one from array 1, there are like 4 elements from the left. Array 2, I have to pick up every one of them. Even if I pick up every one of them, I cannot get 5 elements. Something I know for sure is, if I pick up 0 elements from array 1, it's not possible. Like 0 elements is not possible. Like fine. Can you pick up 1 element from array 1? He says, why not? So I pick up 1 element from array 1, which is 1, the first. How many do we need to pick up from array 2 then? We need to form 5. We need to pick up 4 more. So what I'll do is, I'll end up picking 2, 3, 6, 15. I'll end up picking 2, 3, 6, 15. Right? What will be on the right? The remaining, very simple. 3, 4, 7, 10, 12. So what I've done is I've said pick up 1 from array 1, I've done this, and pick up the remaining. So there were total 5, the remaining 4 got picked up from array. Now can I say this is a valid configuration? I cannot. Why? Because if I try to sort them up, it'll be like 1, 2, 3, 6, 15, and on the right it'll be 3, 4, 7, 10, 12. Is this a sorted array in any means? Even if you draw symmetry, this is not. Why? Because 15 is greater than 3. That cannot be a sorted array. That cannot be a sorted array. How do you recognize that? We'll come to that afterwards. But as of now, this cannot be a valid scenario. Perfect. Okay. Let's go to the next. Next is pick up 2 elements. Okay, let's try to pick up 2 elements. It'll be like 1, 3 from this. Perfect. So how many are remaining? There were 5, we picked up 2, 3 more. Let's pick up the 3 more from the array 2. Picked up. That's the left portion. What will be the right portion? All the remaining elements. 4, 7, 10, 12, and 6. Oh, sorry, my bad. 50. Is this a valid configuration? It isn't. Why? 1, 2, 3, 3, 6. If I try to write them in a sorted order, and this will be 4, 7, 10, 12, 15. Again, the 6 is greater than 4. This is not a valid symmetry. This is not a valid symmetry. Why? Because 6 is on the left. So 2 is also not possible. Perfect. So 2 is also not possible. What is the next job? The next job is maybe pick up 3. Maybe pick up 3. So if I pick up 3, it will be 1, 3, 4. So if I pick up 3 from the array 1, if I pick up 3 from the array 1, how many from array 2? 2 more. Pick up 2 more. That's 2, 3. How many will be left from array 1? It will be like 3 more left. So 7, 10, 12. And over here it will be 6, 15. Is this a valid symmetry? Let's look at this. If I try to write down them in the sorted order, it's like this. And this is like 6, 7, 10, 12, 15. And if you carefully notice, this is a valid symmetry. Because 4 is lesser than 6 and all of these are in the sorted order. So this is a valid symmetry. So what we figured out was, if I pick up exactly 3 elements from array 1 and the remaining from array 2, we get a valid symmetry. You can try out picking 4 elements as well. Try picking out 4 elements. So try picking out 4 elements. It will be like 1, 3, 4, 7 from array 1. And the remaining will be just 1 more we require. So that's 2 from the array 2. And on the top it will be 10, 12. And the remaining will be 3, 6, 15. Again, if you try to write them down, 1, 2, 3, 4, 7. This will be 3, 6, 10, 12, 15. You carefully observe. This is also not a valid symmetry because 7 is greater than 3. It should have been on this portion, this should have been here. It's not a valid symmetry. This is also not a valid symmetry. 4, like picking up 4 elements is not possible. So what did we notice? Picking up 0 not possible, picking up 1 not possible, picking up 2 not possible, picking up 3 possible, picking up 4 not possible, picking up 5 not possible. And that is the max you can pick up because, sorry, there's like 6. 6 is also not possible. So the only thing that is possible is 3. Something we observed is there will always be one valid symmetry where you definitely know 3 from here, 2 from here. There cannot be any other configurations. Got this? This is the first thing you have to understand. How many to pick? If you've understood this, then we'll move to the next. So till now we know one thing, that this problem is being solved on the basis of symmetry, where we decide 3 elements from the array 1 and 2 elements from array 2. This is what we have to get to. After that we'll decide how to find out the median. But that is our first step. But how do we figure out that it's a valid symmetry or not? Imagine you're picking up 4 elements from the array 1 and you're picking up the remaining 1 from array 2. So this is the left portion, this is the right portion. This is the array 1, if you carefully notice, this is the array 1 and this is the array 2. How do you determine that this is a valid symmetry or not? It's very simple. You know one thing for sure. This is array 1, so this will be sorted. This is array 2, so the second line will also be sorted. In order for this to be a valid symmetry, this 7 is on the left. This should be smaller than this 3. This 7 should be smaller than this 3, which is not the case. And this 2 should be smaller than this 10. This 2 should be smaller than this 10, which is not the case. That means the 7 should ideally would have been here. Ideally should have been here, right? That is why it is not, because 7 is greater than 3, so it cannot be on the left. We do not check for this, we do not check for this, no need, because it's from the same array. We just check cross. We just check cross. Now this is where we pick up 3 elements from the array 1 and 2 elements from the array 2. Now this is a valid set. Why? Because this 3 is smaller than 7, which is a valid, and this 4 is smaller than 6, which is valid. Hence, all the elements on the left are smaller than all the elements on the right. Why? Because we already checked for, like, this is an array 1, so this is so. This is array 2, this is so. Just need to make sure that these cross guys are smaller. If that is, all the elements on the left are smaller than all the elements on the right. Hence symmetry. Hence symmetry. Got it? Next. What if we pick up 2 elements from the left? Sorry, 2 elements from the array 1 and 3 elements from the array 2. There's 3, there's 15. That's smaller. Perfect. Perfect. But they cross. 6 is not smaller than 4. 6 is not smaller than 4. Hence, not possible. Not a valid symmetry. So we have also understood how do we figure out it's a valid symmetry or not a valid symmetry. So let's quickly do a recap. Till now we have done 2 points. The first one is the binary search will be on the basis of symmetry, where we determine how many from array 1 will be on the left, how many from array 2 will be on the right. And the second one, how do we determine if it's a valid or an invalid symmetry? We just compare the cross. If they are smaller, if the entire left is smaller than the entire right, it's a valid, otherwise not. But now the question arises, but how do we figure out the median? How do we figure out the median? Very simple, I'll tell you. And this is a valid symmetry. Over here we know these many elements from array 1, these many elements from array 2. How do we figure out the median? So let's probably call them as L1, L2, right 1, right 2. So L1 means left 1 from array 1, L2 means left 2 from array 2, R1 means right 1 from array 1, R2 means right 2 from array 2. Okay? How do we find out the median? Let's go back to the originals, sorted arrays. How do we figure out the median? We took the greatest of all on the left. We took the greatest of all on the left, and we took the smallest of all on the right, and we added them and divided by 2 to get our median. Same thing we do. We know one thing for sure. This array is sorted. So what will be like L1 will be the greatest over here. This array is also sorted. So 3 will be the greatest. So what will be the total greatest? The greatest on the left will be max of L1 comma L2. Quite simple. And what is the smallest on the right? Because that is what you need, the smallest on the right. The entire thing is sorted. So R1 is the smallest on the top, and R2 is the smallest on the array 2. So plus minimum of R1 comma R2 divided by 2. This is how you'll get the median. We'll come to odd afterwards, but as of now, please focus on understanding this particular even thing. Once you've done this, odd is going to be very simple. So till now, we are following a symmetrical pattern to solve this problem where we are figuring out that we need 5 elements on the left. How many from the array 1? How many from the array 2? So if we just focus on array 1, just on array 1. Why? Because if I can determine how many from array 1, the remaining, because total was 5. So if I pick up 3 from array 1, we just need 2 more from array. So from array 2, we will know how much. So let's focus on array 1. How many from array 1 should be our focus? How many from array 2 will automatically be determined? How many from array 1? 0, not possible. 1, not possible. 2, not possible. 3, possible. Will I go and do a linear check? If we do, we fall back to the linear complexity. So we do not. But can I do a binary search? 4 not possible, 5 not possible, 6 not possible. Because that is the maximum elements I can take. Now, I can't see a binary search pattern. Because binary search is technically like not possible, not possible, 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 possible. I can't see a binary search pattern. But I'll tell you how to apply binary search. I know one thing. In the array 1, I can pick up no one, or I can pick all of them. In the array 1, I can pick up no one, or I can pick all of them. Now, how will I determine whether to go left and eliminate right? Eliminate right by going left, or go right by eliminating left. That is what you have to figure out. Basically, if you're somewhere between 4, how do you eliminate the right half? Saying 4 and beyond 4 is not possible. Go and search on the left. How do you do that is what you have to focus. For that, I'll come back to this example, and this example. Let's come back to that. So I'll write over here I'm picking up 4 elements from the left, over here 3, over here 2. So I know this is a possible answer. This is the left half, this is the right half. How do we determine this is the right half? Let's see. We're having 7, and that's greater than 3. Hence, not possible. So any case, this is known as L1. If you remember, L2, R1, R2. Any case, L1 is greater than R1. That means high will be eliminated. Got this? High will be eliminated. We cannot take right. Not possible. We need to reduce the value of 4. 4 is not possible. Reduce the value of 4. This is possible. This is always possible. So we stop there. Stop there. What about if it's a smaller value? Let's look at this. In this case, the 6 is greater than this, which is the L2. And we write it again. L1, L2, R1, R2. If L2 is greater than R1, in that case, the left portion will be eliminated because if 2 is not possible,
Man, it's pretty complex.
you cannot do for small elements. So these will be the conditions for binary search. This is how you determine whether to reduce 4 or whether to increase 2. These will be the conditions. Quite simple. Just pretty observations and we're done. So I said you about the thought process. Now what I'll do is I'll do a dry run by taking a couple of sorted arrays so that the thought process gets into your head, and after that we'll move on to the code. So the first question that I'll ask you is, in the example that we were taking till now, we are doing a binary search on an array of size 6, right? In order to determine how many elements will be fitting the symmetry. And we figured out that 3 elements were fitting the symmetry. And we were doing a binary search on a 6 length array. What will be the time complexity then? Be logarithmic of 6 size because we are doing a binary search on a 6 length array. So, will it be better if I do a binary search on the smaller array? Because the search space is just 4 elements over here. So, the time complexity will be logarithmic of 4. So, ideally, I should never do a binary search to determine how many from the longer array. Rather, I should do a binary search to determine how many from the shorter array. If I do that, time complexity will be lesser. So, I know one thing for sure is I need to do a binary search on the shorter version of the array. Now, if I try to combine them, we'll have 1, 2, 3, 4, which is from here. And we'll have 7, that is 1 element from the array 1. And at the end, 7 and 9 is what we will take, right? This is how it looks like. So we know that we have to do a binary search on how many elements we need from the smaller array. So in this case, I can say, maybe I'll not pick up anything. And that will become my low. And what will be the value of high? Can I say my high will be the maximum that I can pick up from that array 1, which is n1 in this case. And that's basically 4. Because 4 is the maximum number of elements that I can pick up from this particular array, right? Let's try to do a binary search. First time when I try to do a binary search, the mid one, why am I calling it as mid one? Because from array 1, right? So I'm saying pick up two elements from array 1. So I'm saying pick up two elements from array 1, which is basically over here, mid 1. Okay? So if I'm picking up two elements from array 1, how many will I pick up from the array 2? In total, I need 5. 5 minus 2 will be 3, so I'll pick up 3 from array 1, 3 from array 2 rather, 3 from array 2. So it'll be pointing to index 3. Perfect. So if I try to segregate them, can I say 2 from array 1, which is basically 7 and 12, and 3 from array 2, which is basically 1, 2, 3. And can I say from the right, it'll be 14, 15. Point to observe is mid 1, index is pointing to 14, and 4, 9, 11, and mid 2 index is pointing to this.
Bro,
And 15 from array 3. Perfect. So if I try to segregate them, can I say 2 from array 1, which is basically 2 elements from array 1. How many will I pick up from the array 2? In total, I need 5. 5 minus 2 will be 3, so I'll pick up 3 from array 1, 3 from array 2 rather.
Okay, 1 minute. So there are total 4 elements in the. There are 4 elements, and you took either 0, 2, or 4, and here you are taking. So mid minus, okay, like whatever the number of you elements that you are taking. So first you will decide, and if it is mid, or you can say median value that you are looking for in the even number. So mid minus 2, mid, you got the mid, 1038. I'm hoping that he will come around 11, then it will be easy. So man, mid, I know this one will be. How long I'm streaming? I don't know. I think I'm taking too much time. Okay, maybe I need to cut off the streaming, and I'll continue the video. Let me see how much time I have spent. Oh, I think I'm taking too much time. Okay, maybe I need to cut off the streaming, and I'll continue the video. Man, it's 1 hour 21 minutes. But let me continue. Otherwise, it will be I will forget it. Okay, let me continue, and let me watch video.
3 from array 2. So it'll be pointing to index 3. Perfect. So if I try to segregate them,
1 minute.
can I say 2
1
from
minute, bro. So how many elements we are taking from this? We are taking 2 elements from the first. So 2 elements means index will be 1. I mean, yeah. What? Why are you taking index as mid value?
array 1, which is basically 7 and 12, and 3 from array 2, which is basically 1, 2, 3. And can I say from the right, it'll be 14, 15. Point to observe is mid 1, index is pointing to 14, and 4, 9, 11, and mid 2 index is pointing to this. And if you remember, this was called as L1, L2, R1, R2. Is this a valid symmetry? No, this is not a valid symmetry. How did you figure that out? Because L1 is greater than R2. And let's
L1. Okay. L1 greater than R2. L1. Oh man. I just need to think more on it. L1, L2, R1, R2. Logically, it should be something like ideal condition. L1 should be less than R2. R1. If L1 is greater than R2, that means L1 greater than
Quickly go and check out the condition. L1 greater than R2. The high has to reduce because this is not possible. This is not possible.
L1 greater than R2. Why high has to reduce? Okay, we are considering the first array or the array that has a small number of elements. So if L1 is bigger than R2, that means this element go towards right and R1 should come, R2 should come here. Yeah, so R2 should be part of this and L1 should be part of the another. So L1 should be part of another, that means we need to reduce the number that we are taking, then only that will be go towards right. Okay, so L1 low mid plus 1, okay, high mid minus 1, and if L2 greater than R1, that means L2 and R1. So L2 should go towards right and R1 should come here. And if we want R1 in the left part of it, then that means we wanted to increase the low value. Then only or you have to increase the mid value. That's why. So I mean you just wanted to consider more number from L1. So definitely you can say if L1 is greater than R2, that means we need to consider high, we need to reduce high equals to mid minus 1 and else low equals to mid plus 1. Okay, got it.
It has to reduce. So what will you do? You will go back and you will say this is not possible. So the entire right half is not possible. Hence, you trim off the 2 to 4 section and you will be over here. Perfect. This is what you'll do. I'll quickly erase this off so that we have better clarity. Perfect. Done. So you're starting at 0 to 1. Anything from 2 to 4 is gone now. What will be the mid? This time the mid will be pointing to 0. So I'm saying I'm not going to pick up anything. The mid one is pointing to 0. What will be mid 2? Mid 2 will say I'll pick up 5 elements from you. So point to observe again. Mid 1 is at 0. And where is mid 2? Over here, that's 5. Now try to segregate. On the left of this, there is no one. There's no one. Remember this, there's no one. There's no one from array 1. And 0, 1, 2, 3, 4, 9. Is it? No, sorry, my bad.
9, 11.
1, 2, 3, 4, 9 from array 2. And on the right, 7, 12, 14, 15, and over here, 11. So again, if I have to write down the indexes, this is mid 1, this is mid 2, and this is R1, R2, L2. You don't have an L1. Remember, if you don't have an L1, since this is your left portion, they always try to take a smaller values because it's not there. And you want to compare if it is.
And let me stop streaming. हेलो हाँ 1 मिनट आ रहा है भैया Ah, God. Oh, my stream was working. Stop streaming.